So the aim of my talk today is to really provide you with a very broad understanding of this statistical technique, and hopefully by the end of my talk you'll be able to get a sense of what it is and whether you'd be interested in applying it or not before you open one of the very many complicated statistical textbooks which exist out there, which otherwise risks sort of turning you off it. And the aim of this talk then, as I said, is to offer a very broad overview of event history analysis. I want to introduce some of the key concepts behind the analyses of change in events. And I also hope to finish the talk with a practical example of research that applies event history analysis. And I'll just spend, I think, the last sort of 10 to 15 minutes of the talk just going into detail in one research paper that I used event history analysis on to look at transitions to divorce. Okay, so in a nutshell, event history analysis is a technique that allows researchers to study the social processes that lead to the occurrence of an event. Actually, that make sure mine is on silent as well. And an event is a change then from one state to another, and is essentially your dependent variable in event history analysis. It's a categorical, discrete dependent variable. And different examples of that will be given in a bit, but basically the origins of event history analysis are in the biomedical sphere. But having said that, this statistical technique is used across a very large range of academic disciplines, and consequentially this one technique has a very broad range of terminologies which can be very confusing for those who start using it. So event history analysis is often the term used in sociology, not always. Sometimes it's called survival analysis, duration analysis, as well as more common in economics. Failure time analysis, hazard analysis is all the same thing. Sometimes it's called transition analysis, and what they call it in engineering, I think, is reliability analysis, and it's all the same statistical technique. Essentially, it concerns change, and changing your dependent variable, yt or yit. And that change in the parlance of the technique is generally referred to as a transition. And just to take a broad range of examples of different transitions you can look at, in labor economics or economic sociology, there's an awful lot of work that looks at transitions across labor market status. Typically, let's say from unemployment to employment, we'd be interested in how long it would take someone who's unemployed to enter into a job. Another one of more interest to demographers or sociologists of the family would be transitions in and out of marriage, or how long the average marriage lasts, which variables may precipitate or a divorce or a separation, which ones are protective factors. For welfare, the welfare economists or campaigners amongst you, there's been analyses of what transitions can help people get out of poverty, how long people remain in poverty, what factors can help them obtain financial security. Class is one area as well that is analysed using event history analyses, the timing and the precipitating factors out of different social classes. It's used in psychology. And there's an awful lot of work in the area of criminology as well, looking at recidivism, so which factors predict further criminality. And frequently your dependent variable will be a dichotomous variable. It will be 0, 1, but the way it is measured in your data set will not just be a sort of a 0 variable. So you will time the analysis, you will see how long it takes someone before they actually make a transition to event. Okay, it doesn't need to be just a dichotomous, it can be a multiple categorical variable. So you may be interested in transitions across labour market states, for instance. And so the example I was going to give about in the area of criminology is what's frequently done is, let's say you have juvenile offenders are put on a program, and you typically analyse how long it takes for them to re-enter the criminal justice system and whether the program was successful or not. So it's all about timing of events. Okay? It's crucial. Here's the timing. All the examples I've given up until now have been about the individual, and that's just from my own personal research interests. But of course, the unit of analysis doesn't need to be the individual. So if you're interested in management, you could be interested in firms, transitions from firms or changes at different units, so the household or country level as well is done. As is frequently done in political science, actually, you look at transitions from democratic states or in and out of different governments, how long governments last, for instance. Again, just introduce you to some of the terminology. The different values of yt, your dependent variable, tend to be termed its state space. And one of the things you need to think about very carefully when you're constructing your analysis and your data set is when the timing of the event you're trying to measure actually occurs. And this is quite important because most of us have data sets that are collected every year. And so you need to ask yourself, well, for instance, if I'm interested in divorce and in year 1, the person said they were married and maybe in year 3, they're not married, do I identify them as divorced or separated in year 3? Do I identify it as some stage between year 2 and 3? Maybe if they say they're separated in year 2, do I put that as the timing of the event? And these are actually quite theoretical issues that you just need to tease out in your own analyses, but they are quite important for your assessment of your transitions. One of the main interest in using event history analyses is to try to approximate a causal model of outcome. And in particular, researchers tend to be interested in the impact of key covariates on the risk of transition. So because you have a large period of time where you're analyzing people in principle, you can see whether they've had a change in a key covariate before a transition has occurred, and therefore you're in a slightly better position to talk about causality than you would be in other situations. Though there's an awful lot of debate about whether those variables are truly measuring causality or not. One of the largest parts of time that one spends doing event history analysis, and very few people or textbooks discuss this, is the time you spend actually just creating your data set. And so I want to spend just a small amount of time just talking about the format of the longitudinal data set generated for an event history analysis. According to Paul Allison, and he's one of the foremost writers on this topic, he regards one of the best research designs for event history analysis to be prospective. And so that would essentially mean that if you've got a panel data set, you interview someone in year 1, you find out what marital status they have, and then in year 2 and year 3, you gather the information prospectively, and so you have less problems with bias with this research design. Having said that, there's a huge, culture of research that has been done using retrospective data, because of course retrospective data lends itself very, very well to event history analyses, because all of the information has already been collected for this technique in particular. There are many limitations associated with retrospective data, including recall error, recall bias, social desirability bias, and we don't like to admit to our errors or our fallibilities in the past. There's also large problems around accuracy of recall with these retrospective data, which need to be at least mentioned in your paper if you're using retrospective data. So, for instance, we know that recall accuracy tends to be very high for marital and fertility history. We know when our children are born. We know when we got married. However, when it comes to attitudes or values, we tend not to really remember what they were 10 years ago or 5 years ago. Even when it comes to unemployment, recent research suggests that there's a 3-year cutoff after which we don't really remember our labour market dynamics very well. So all of this needs to be borne in mind when you're analysing these data. And I've a friend who actually analysed the BHPS recently, looking at birth of children, and there's a large difference, I think, between the actual data which was collected from parents and from the survey itself. And a very large number of parents could identify the date of their children, but they kind of forgot their age after that. And most of them were like 10 or 5, and very large peaks around that. So there's an awful lot of approximation which which you need to be careful of. For those of you who've never done any sort of longitudinal analyses, I just wanted to mention a couple of data sets which have both short-term and long-term retrospective data structures. So the SHARE retrospective survey, which has just been collected recently in 2009, is a good example one, as is the BHPS. And other examples can, of course, be found on the ESDS longitudinal website. But just to spend a couple of minutes talking about ShareLife. ShareLife focuses on people's life histories. SHARE, which is the name of the data set, stands for the Survey of Health and Aging and Retirement in Europe. So it focuses on people aged 50 plus across Europe. The data set covers 30,000 people across 14 European countries. And the respondents are representative of the European population, as I said, over 50. The countries that they collect information of include 2 countries from social democratic sort of regimes, Denmark and Sweden. The more conservative mainstream European countries, Austria, France, Germany, Switzerland, Belgium, and the Netherlands. We have some Mediterranean countries as well, Spain, Italy, and Greece, as well as some new emerging economies, the Czech Republic and Poland. And all samples from these countries have had a large life history calendar collected for them. And essentially what was provided for them was, I think it was a Palm Pilot data collection. I'm not certain about that, but anyway, they're presented with a screen which lists all of the years of the respondent's life, starting from, I'm not too sure actually what ages, sometime in the teens. And it follows them from birth actually to present, there you go. And the information on the event that occurred in these years is then collected of respondents. So all the information is, what were you doing at this age? You know, what sort of education level did you have at this age, etc. And so that allows you sort of analyze all these events over an entire person's life. One of the innovations in this collection of this data was the introduction of key sort of national and world events to try to spark off people's information. So what were you doing for instance, what were you doing in September 2001, for instance, when the World Trade Center fell down. The BHPS also has some retrospective data structure, and it, like many employment-focused data sets, have what I'd call a sort of a short-term retrospective calendar data format, so that people are very frequently asked, what have you been doing in the past year? What have you been doing the past year and a half? And that's often about employment status, and we'll know whether they're employed or unemployed. And this data is very easily analysed using event history analysis in terms of transitions in and out of labour market states. Okay, so practically, to conduct an event history analysis, you need the following 3 to 4 variables. Because you're looking at change and at longitudinal data, you're going to need an identifier variable, an ID variable, which identifies the rows or links all of the observations per unit of analysis. So typically, if it's an individual, you'll have an ID number for that person, or a household, or firm indeed. Your dependent variable then is the categorical variable, which measures the change of event of interest over time. And then the third vital variable is your timing variable that identifies when a transition occurs for a unit of analysis. So you need a sort of a starting point and an ending point of your transition. And those 3 variables would allow you to do a very basic event history analysis, just a bivariate assessment of a transition and the timing of a transition over time. And it has to be said that there are a few statistical techniques, I think, where the bivariate analysis can be really, really informative and illustrative and interesting. But of course, what many people are trying to do when they're using event history analysis is to try to identify variables which predict transitions or increase or inhibit transitions. So in that case, of course, you'll need a series of covariates which may or may not change with time, depending on your data structure. So I got sort of a figure here identifying different types of data structures you could possibly have, and just discuss very briefly how event history analysis deals with it. Let's just imagine we have a panel data set going from T0 to T plus X, and we want to measure people who divorce from their first marriage. Let's say we have some people here at A who get married and divorce before they enter our sample. We can't do anything about that, and this is a bit of a problem for event history analysis. We could also have people who become married and are married when our data period starts and become divorced during our observation window. That's not ideal, but there are relatively advanced statistical techniques to try to cope with it, but most people tend to avoid using this type of data. The latter two data types are perfect for an event history analysis. So the first type would be we observe before and after a person makes a transition. So let's say this person is single, falls in love, gets married, and then divorces within our observation window. We can analyze what their transition, what predicts their transition very well. But also, and this is one of the reasons why event history analysis started getting an awful lot of investment done in it, it can deal with situation D very well, which occurs an awful lot. And situation D involves situations where we observe an individual getting married, and they remain married after the end of our data period, and we don't actually know whether they become divorced or separated or remain married after our time period. And these people here at D are deemed censored, and it's one of the tricks of event history analyses for these type of data. And this basically says what I've just described now, although it introduces the terms left-hand censoring and right-hand censoring, which is used often in the terminology as well. So we have no problem with right-hand censoring, which was the final instance, which is episode D, whereas any problems with left censoring are much more complicated to deal with. Just one other word on censoring is that we have to make the assumption that we have non-informative censoring going on for the final example I gave you, where we observe someone and they remain married after the end of our data observation window. And while EHA, event history analysis, can in principle deal with censored data very well, in principle that censoring should be non-informative. And by that I mean non-informative censorship is if individual A is censored at T+2, for instance, because they drop out of the sample, we have to work on the assumption that individual A is similar to this person who doesn't drop out of the sample. So if I go back to our example here, if we have an awful lot of people who, for instance, who we observe entering marriage and are maybe not very similar at all to these people here, and are generally drop out of the sample because they're quarreling so much and their life is miserable and they're generally unhappy, we're going to have a slightly biased sample going on. So we're working on the assumption that those who drop out of the data set, and this again assumes they're just dropping out, uniformly. We have people who drop in and out of data sets as well. But we have to work on the assumption that they're no different to those who stay in. If they are, we don't yet have a way of doing that. So I just wanted to spend a small amount of time just showing you what a prepared event history data set looks like. Because I remember when I started using this, I had no idea. I couldn't find anywhere that explained it very well. But basically, if you look at the most simple type of event history analysis, which is a single episode event history data set, you'd have basically one row per person, and you would have information on the event. So this is our dependent variable here. And we have information on when the date began and when it ended, and further information on key covariates concerning the person. So for instance, if we look here at person number 4 and person number 5, these people are censored. They have zeros on their event. We've no observations for them entering the event we're particularly interested in. And the way the software programs that you use, and there are a very broad variety that can be used here. I use STATA, but
but SPSS can also be used, as can SAS, for instance, and others, no doubt, that I'm not aware of. But the software programs you use will use this information on the timing of the event to sort of stretch out the data to the right length for your analysis of change in the dependent variable. This is just an example of a multi-episode event history data set. And then, so if I go to person number 2 here, for instance, we can see that we're looking at various transitions here. So we've got this person entered employment between 1992 and 1995. Then in 1995 to 2001, they were a temporary worker. And then 2001 to 2002, they entered a second temporary contract. And again, this is an example of how you can look at multiple states and transitions across multiple states over time. It's important, particularly actually in a talk like this, to recognize why you're using event history models rather than linear regression, for instance. And while in the past it was quite common for duration type data to be analyzed using standard linear regression techniques, that's no longer the case. And the biggest problem and the biggest reasons why we don't use just standard linear regression is due to the problem associated with censored data. And this is around 20 years ago. People did actually include a dichotomous variable in regression to indicate whether there was censorship, but these days that would no longer, unfortunately, get past peer review. You tend to be told, oh, there's event history data techniques, why don't you try these instead? Additionally, one of the strengths of event history analysis, though, is that it does allow you to approximate a causal mechanism behind the event occurrence. You can control for censored data more convincingly, and you can also, in principle, examine the impact of a time-varying covariate on outcome with greater ease. So, yeah, I mean, I keep saying this, but it's worth repeating. It's a method that analyzes the occurrence of events. Often in the literature, they identify an event as a qualitative change in your dependent variable from state J to K. So this is the state space that I've been speaking about. And an example, again, would be examining exits from unemployment, for instance, towards employment. And unemployment would be defined as J, and employment would be identified as state K. All the standard approaches to event history analysis assume that your dependent variable is the outcome of a random process. Therefore, YT is a random variable with a probability distribution. I won't be spending much time talking about the various different probability distributions associated with event history analyses, but your theoretical assumptions as well as empirical assessment of the dependent variable are very important to your model choice in event history analyses, because you're not just looking at your dependent variable and your independent variables, you're also trying to understand what shape your transitions over time are likely to take. Are they going to be increasing or decreasing over time, and whether that is going to have an impact on the variables you have in your models. So what I have here is basically a bivariate analysis, an event history analysis. And this basically just shows transitions of temporary workers to permanent work in 4 different countries. Okay? And it very simply just analyzes the rate of change in the transition to a permanent job over time. So we have time starting at 0 months up to 60 months here. The 3 different lines represent temporary workers from, 4 different lines rather, represent temporary workers from 4 different countries. And what's interesting, and I think it sort of underscores the importance of event history analysis, is how much I guess the horses in the race vary over time. And so if we start off, at the beginning where we have, and just before I go on actually, to explain this, if no temporary workers had a permanent job, the lines here would go straight up at the top of the graph, okay? And as more and more of them leave a temporary job to permanent work, we have a decrease in the proportions who remain. And again, this is one of the quirks of event history analysis. It started in the biomedical sphere, so we talk about surviving a transition because often they looked at death and how long people survived their illnesses. But anyway, so we still use that funny terminology in disciplines that no longer make sense. But basically, if we start off at this period of about a year, we see that temporary workers in the UK have the highest transition rates out of temporary work to permanent work. However, if we follow them through time, after around 2 years, we find that actually it's in West Germany where temporary workers are more likely to go on to obtain a permanent contract. And I guess that's the whole point of having something like this that allows you to look at variation over time, is you can give different answers to the question, in which country is it best to accept a temporary contract? Well, up to here it's the UK, then it's Germany, and actually, the differences remain, but they could converge and go up and down. So that was the point of that slide. Often, though, I don't know why, often though, when people discuss their survivor functions in event history analysis, you get a little table like this, which isn't as illustrative, but similarly, you can see which proportions have left a transition for a different event at different time periods, after a year, 3 years, 4 years, in this table. You're not going to get away with no statistics. So I'm going to spend just a small amount of time talking about the hazard function of associated event history analysis. And it's basically one of the key statistical concepts in an event history analysis. And what the hazard function tries to quantify is the probability that an event will occur in the very small interval between t and a change, denoted by the triangle, in t, conditional on the individual surviving to t. Okay? And I guess that's a very long-winded way of saying, if you're looking at someone making a transition, let's say from marriage to divorce, once they divorce, they drop out of the sample. You can't experience divorce several times in one marriage. And it's very important in one of these analyses that once you experience the event, that you're removed from the sample, because otherwise we can't get a sense of the relative risks over time. This is the formula for it. So again, we've got the hazard function of making a transition from state J to K, with the likelihood of the transition occurring between t and the very small change of interval between of t. Okay. One of the things that's useful to think of in terms of a hazard, when you're thinking of hazard function, is to try to think of them as a property of individuals. I can't remember which author who wrote this. I think it's Paul Allison, but I could be wrong. But he describes a situation where you should try to think of your own personal risk of dying. Okay? It's rather macabre. And so you wake up in the morning in your bed in a wealthy Western European country with no war, in a time of peace, and your risks of dying are very, very low. And you get up, you get dressed, you leave the house, maybe get on your bicycle, and you decide to cycle through work through the rush hour traffic, and your risks of dying start increasing a little bit. And then as you get to work, you get off your bike and you tie it up, or preferably lock it, and you go into your office, and again your risks of death start sinking again. And this is a little bit what a hazard function will try to identify for groups of people in your processes that you're looking at. Practically, the conceptualization of a hazard function can actually be fairly straightforward. So I just have two examples here. One is just assuming we have a sample of 1,000 single women that we observe over a period of 1 month. Okay? And after 1 month's time, 25 of those 1,000 are no longer single. Okay? They've made a transition. Now, the time constant hazard for the women of entering a relationship is basically just those 25 women divided by the sample. And so it's 0.025, if you have a little calculator, you don't like division. And the reciprocal of that then, which is the amount of time it actually takes for you to no longer be single as an average, is just 1 divided by 0.25, which equals to 40. That's the amount of time the average woman can expect to remain single, which is 40 months before she enters a relationship, if she is the same as all the other people in that sample. Okay? Another example then, and this one looks at variation over time, looks at, for instance, cyclists' risks of injury. So you can think of, the previous example of your own mortality risk, or maybe injury risk. And so let's say we start with a sample of 500 cyclists, and this sample is our risk set. This is, again, the terminology used. And we observe that 33 of them get injured over a 2-year period. And so we interview them first in January, and then interview them at 6-month intervals to establish whether any of them have been injured while cycling. And so basically this is what a hazard function does. It's a really simple little statistic. So we start off at month 0. In month 0, the number of cyclists who get injured are 0. Our risk set is 500, but they're all at risk potentially of injury. And our hazard function at the moment is 0, so there's no risk of injury at the very beginning. After 6 months, we re-interviewed them and we found that 3 of them got injured. And so basically just 3 divided by 500 is estimated risk of injury, which is 0.006. By month 12, our risk set has got smaller because we're not looking at risk of repeated injury, we're looking at the risk of first instance of injury. And so in this instance, the estimated risk of injury is 11 divided by 497. And so it's very important to bear that in mind. The denominator changes according to the number of people who remain at risk of injury at each time point. And it allows, it allows for control then of who remains at injury at each point in time. And that's the essential, idea behind a hazard function. So, right on time. So I've just got a slide with recommended readings before I go on to give my practical example of event history analyses. I've put little stars beside the readings that I thought were of particular use. If you're practically minded, I'd go straight to using a book that applies, the technique to a data set. I certainly am. I find it much more useful to understand a technique with an applied example. So something like Blossfeld's book, Event History Analysis with STATA, if STATA is your program. If not, there are other textbooks out there which use other programs. Otherwise, this is a very nice and accessible read on the general statistical concepts behind event history analysis, again with some practical examples, but I like actually working with the data set. So to finish my talk, I just wanted to spend 10 minutes around working through event history analysis that I did with a colleague on a paper here which looks at the impact of women's employment on marital stability in 3 different countries, in Great Britain, West Germany, and the United States. And we could have done event history analysis the amount of time it took us to eventually get accepted. I think it's around 4 or 5 years on, they've agreed to publish it. But essentially the principal research question was, does part-time work enhance marital stability in these 3 different countries? And do the different institutional contexts vary female employment effects on divorce risks in these 3 countries? So we selected couples as they first entered into marriage, and the timing that they entered, and then this starts getting more complicated now as you look at more data sets. So we looked for Germany and the German socioeconomic panel and the panel study of income dynamics for Germany and the USA. We looked at entry into first marriage between 85 and 95. And then we basically followed people through time for a long period, around 10 years, to see whether they remained in marriage or not, and which were the predictors of divorce. For the BHPS started much later than the GSOP and the PSID, so we start in the 90s, but we follow them for a longer period of time. For those of you who are eagle-eyed, we don't follow the Americans very long because they changed the panel structure of the PSID, so we had to stop a little earlier. So the time periods don't overlap perfectly. This resulted in our risk set of 559 couples for Germany's very lucky number of 666 couples in the UK and 502 couples in the USA. The word couple years or person years is often used in event history analysis. It's just basically the number of couples multiplied by the number of time periods we observed them for. And that was basically what our sample looked like. So we two main theories sort of cradling our research question about why would part-time work be good for marriage. And these theories were one, the independence hypothesis, and two is the flexibility hypothesis. The independence hypothesis is sort of a Machiavellian game theoretical perspective coined by Gary Becker, Nobel laureate, and he predicted that wives' employment in general will increase the risk of divorce. He predicted this on the assumption that the more dependent wives are on their husbands, the less likely they will want to divorce because they won't have any money if they do, essentially. This independence hypothesis is assumed to be sort of like I guess, generic across countries. And so this independence hypothesis would argue that the smallest divorce risk will be found amongst couples where the wife remains out of the labour market. A somewhat greater risk will occur amongst couples where the wife works part-time, so she's not entirely dependent, whereas the greatest risk will be found amongst full-time dual earner couples, because she can go, to hell with this, I'm off. On the flip side, based from some of Oppenheimer's arguments in the late 90s, we have the flexibility hypothesis. And this rather argues that wives' employment, particularly over more recent periods, should predict greater marital stability. And she argued this because she was arguing that a gender division of paid and unpaid labour within the family is increasingly a high-risk strategy, leaving households vulnerable to economic downturns. And given the erosion of the male breadwinner model and the erosion of employment security in general, having two earners in a household would predict greater marital stability because they're both interdependent and both need each other. And so this led to a series of hypotheses where the smallest risk of divorce would be amongst couples where the wife works full-time, and the greatest risk of divorce would be amongst couples where the wife is not working because she's not contributing to the financial security of the home. So that was the two opposing hypotheses. The findings in this area are diverging. So if you look at women's employment hours and its effect on divorce risk as a continuous variable, many have found that the higher women's hours are, the higher the divorce risk in Holland, Sweden, Hungary, and in the UK. Okay, using various different data sets. My colleague, Lynn Cook, found that amongst a recent cohort of West German first married couples, women's employment hours only significantly increased divorce risk after the birth of the first child. So it suggested actually it wasn't about women's working hours, but had to do with children in the household, which caused problems in Germany. Again, in the USA, the results are a little more mixed. So Rogers established that the risk of employment associated with risk of divorce, rather associated with wives' employment hours, was offset when husbands increased their share of housework, for instance. So the question became which are the primary predictors of divorce. So just time-honored tradition from my background, I have to give you my hypotheses by country. But we argued that part-time work in Germany would be more predictive of stable marriages, most predictive of stable marriages, and that the effect is probably stronger than the UK due to, again, the high quality of part-time work. I don't have the time to go into that now. But we thought that the quality of job quality would be quite important in our assessment of these predictors. We thought that in the UK, part-time work would be predictive of more stable marriages, but given the quality of part-time jobs in the UK, it may have less of an effect than in Germany. And in the USA, we thought that strong market pressures basically would make part-time work less desirable. So the two full-time worker earner couple would be the most stable. withholding the results, just so you keep listening for a little longer. But the dependent variable, again, just in terms of what I've been talking about up until now, in terms of the state space and the transition event, was where the divorce occurs. So we start the clock when they become married, when they become first married, and stop the clock when they become divorced or they are censored from the data set by dropping out. The independent variables were women's working time, which have key hypotheses about. And we also looked at the effect of children, of interaction terms with children, and include various controls in the model. So in many ways, particularly if you have a discrete structure to your event history data set, once you have set your data set up for analysis using event history analysis techniques, what you're applying in more cases than not is a standard logistic model. And so it can be fairly intuitive once you've done the hard work of data preparation. I was too lazy to make this table more legible, so I thought I'd just hand out little handouts instead. And essentially these are our results. And so, as I said, once you do your event history analysis and you set it up, you frequently analyze it just as a logistic regression. And so what we found here in terms of the predictors of divorce risk was that in Germany was our only country that really stood up properly to our hypotheses. In Germany, when a woman works part-time, the couple is significantly less likely to divorce. There were no other countries where this was true, with the one exception of our second model in the United States. And our second model basically just includes an interaction term of part-time working and the presence of children in the home. And what we found in the USA was that if a woman works part-time and she has children, this increases divorce. What? Yes, increases the relative risk of divorce. Oh, I forgot that was up. Quite dramatically. The other thing worth bringing your attention to is that in an event history, standard event history model, you measure time in your analysis to some extent, or you control for it to some extent. And so we have two variables here which measure the years since marriage, and so that increases as you carry on through your analysis through time, as well as its square. And so these have the predicted effects. So essentially the conclusions were that wives' part-time work predicts lower divorce in Germany. The UK has no effect of wives' employment on risk of divorce. And for the US, mothers' part-time employment significantly lowers divorce risk, even though the coefficient suggests it didn't. In terms of the question of whether we have a death of the male breadwinner, which is what Oppenheimer's hypothesis was, it's worth saying that nowhere did we find that specialization significantly enhanced marital stability. However, we still did find evidence of gender specialization being very strong. In Germany and the UK, for instance, there was a higher divorce risk associated with a husband being non-employed than other subgroups. If you can see that. So we've got a significant level at 0.10 of higher divorce rates if the husband is non-employed in Germany, and a strong, significant negative effect in Great Britain. We do not have a death of the male breadwinner at all. In fact, it appears that couples are punishing male unemployed people by divorce in these two countries.